Good morning. How's everyone doing? It's Advent of Code and it's day 23. Well. We have a few minutes left. Day 23 is starting. And today is Monday. And I think for many people it's going to be a holiday today. I took a few days off from work as well. So that I can do fun things like Advent of Code and learn some new skills. So for today, I have not prepared my code yet. So in the meantime, as we are waiting for day 23 to be released, I'm going to start with my Python file as usual. And for all of you who are already preparing to start on the next puzzle, good luck to you all. And once you're done, do have a look and come here and see if I finished the puzzle, and if I haven't, maybe help me out a little bit, or share your solution and show us how you did it. So I guess today is going to be an int code puzzle, because most of the days so far, the odd days have been an int code puzzle. So to prepare for that, I will make an instance of one. Just call it computer. And the last version was that one from day 9. So that means that since day 9 we haven't actually changed our int code computer at all. And probably I need to load a program from a file, day23/input. Okay, and maybe I'll turn debug mode off. And let's see that we can run it. Well, of course, our input file is not going to be there. So that's fine. We'll just have to wait a little bit. Three days left. I almost can't believe it. Streaming for 25 days straight. Hey Akash, 1030 Rock, thank you for following. Welcome on the stream. And hey G, good morning. So good luck everyone. We're almost there. Almost time. Getting into the zone. There we go. Have fun. Day 23, category 6. The droids have finished repairing as much of the ship as they can. Their report indicates that this was a category 6 disaster. Not because it was that bad, but because it destroyed the stockpile of category 6 network cables, as well as most of the ship's network infrastructure. You'll need to rebuild the network from scratch. The computers on the network are standard int code computers that communicate by sending packets to each other. There are 50 of them in total, each running a copy of the same network interface controller software. So we're gonna run 50 int code computers. That might be quite heavy on our CPU. And the puzzle input is this controller software. So let's have a look. It's not super big. I'm not sure if it matters whether or not it's big, because the input for a program can also contain data, like memory. So there we go. How does it work? So they're sending packets to each other, and they have network addresses 0 till 49. When each computer boots up, it will request its network address via a single input instruction. Be sure to give each computer a unique address, so we're kind of implementing DHCP. Once a computer has received its network address, it will begin doing work and communicating over the network by sending and receiving packets. All packets contain two values named X and Y. Packets sent to a computer are queued by the recipient and read in the order they are received. To send a packet to another computer, the NIC will use 3 output instructions that provide the destination address of the packet, followed by its X and Y values. For example, 10, 20, 30 means send X and X20, Y30 to computer 10. To receive a packet, the NIC will use an input instruction. If the incoming packet queue is empty, provide -1. Otherwise, provide the X value of the next packet. The computer will then use a second input instruction to receive the Y value of the same packet. Once both values of the packet are read in this way, the packet is removed. Note that these input and output instructions never block. Okay, so that means that if it doesn't receive input, it should keep running. But what is the purpose of that? I guess it only means that it would try to receive an input and then we have to provide it some input like right away, so we can just say -1 to it. Specifically, output instructions do not wait for the sent packet to be received. The computer might send multiple packets before receiving any. Similarly, input instructions do not wait for a packet to arrive. If no packet is waiting, input instructions should receive -1. Boot up all 50 computers and attach them to your network. What is the Y value of the first packet sent to address 255? Okay. So we don't have computers, but we don't have a computer, but we have computers. And I'll call them NICs to stay in the style of this puzzle. And maybe we'll actually create a class called NIC. And a class will boot an int code computer on init with the code like this. Maybe I'll pass a program as an input actually. Then we can actually load and pass the program like this. And our first function is called part1. That's where we are going to set up everything for part 1. And let's load the program. Load, I think I have a function somewhere, load from file it's called, or load path. Let's see where it is. Oh yeah, it was part of some other function. Well, you know what? I can just copy it. Load from file. It's basically just a one-liner anyway. So the program is like this. And when we load it, do we get a copy of it? Yes, we do get a copy of it. So it's day23 input.txt. And we'll run it with that program. So we have our NICs, and that is 1. Wow, Alex already done in less than 5 minutes. That's so fast. For I in range 0 till, how many do we have? 50, I think. And we should also get a name for our program, a name for our int code computer. Maybe address. That equals the address. And now we're gonna run all 50 of them. And they are going to block with while waiting for input. And so how can we make sure that once it tries to get input and there isn't anything, that will just return -1. So maybe we can actually use a generator for that. Let's call it input buffer. And that one will always yield -1. But if we send something to it, next input, then we can actually yield the next input. Maybe not. So once we yield, hold on. So we can send something to the input buffer, and that is actually not entirely sure how I will do it. Maybe I'll just run the computer, and when it's halting and there's nothing on the input buffer, then we'll just say -1 and that's it. I guess so. So we'll have a function to run the computer. Maybe it's called boot. And for each NIC in the NICs, we're going to boot them. And then that means that the computer is going to run. And I want to assign it to itself so that we can access it from the boot function. Equals computer. And how did we call it? Run program with no input. And then as long as it's running while true, yeah, then if it's waiting for input, well, if it's not waiting for input, then we're gonna break, and otherwise we'll check our input queue, receive some kind of value, maybe x and y, and that will have a queue, which is just a list, and we'll append to the list. And if the computer is waiting for input, then we're going to pass the input from the queue on it, only if we have something on the queue. Like this. Maybe we can do a while loop. Maybe we can just do a while loop and pop from the buffer. And after that, we'll just pass -1 to indicate that we're done. So we're not really checking if we have anything on the input, we'll just pass -1 when we're done. Okay, apparently this should be with small letters, well, makes sense. Okay, well, there we go. Let's see if that works. Of course, when the computer is done running, it might also send some output. And how does it work? Do we have to continuously monitor for output? It says that it doesn't wait for packets to be sent, actually. I think I might have made an output handler in the computer. Let's see. In day 7, in day 5, I do have an output handler here. And if there is an output handler, I'm going to call it. So that means I can set up an output handler, and that will help. Right. I think I'm going to pass an output handler from the outside because the NIC doesn't know which are the other computers. Well, unless when I boot, I would just pass the whole list of NICs. I think that's what I'll do. And the output handler will send to the NICs, so the NICs need to be stored. And maybe I'll set it up here. So that is going to be a lambda, which receives an input, like a value. And then maybe, let's see, so the first address is going to be the computer's address, and the second and third values rather are the x and y coordinates. So we have to kind of keep track of how many outputs we have gathered so far. So maybe what I'll do is I'll create an output function here where I can set up that logic. So value, maybe I'll just call it output handler. And then we can just attach our own output handler there. And output handler will keep track of how many outputs are received. So it starts by 0, and then maybe we'll have an output buffer also, just like an empty list. Output buffer. we'll append a value, and if our output buffer has exactly length 3, then we're actually going to send it, each one of them, to the destination address. So that means that we have a destination, an X and a Y in the output buffer. And Alex has finished part 2 also. Wow. Okay, so not a very difficult one today maybe, or one that requires a lot of mathematics. So we know the destination, and then we're going to look at our NICs and tell it to receive our data. That means X and Y. And our output buffer is going to be cleared. Like that. And when we do boot, we need to pass all the NICs. That is it. Just running it. And then in the end, we have to say what is the Y value of the first packet sent. Adders 255. Oh. But we have 50 computers, so this is kind of out of range, right? So when we send something to 255, then we have to break or something. Maybe here. Receive, no. So when we are sending here, okay, so when the destination is 255, then we're actually going to have to stop. And I'll do it right now by raising a general exception. Hey Alex, good morning. So that was quick, 12 minutes only. Not so hard, or how was it? So we received X and Y. Oops, like this. I'm writing a lot of lines of code here. Yes, because I'm doing it OOP style, and because my VMs don't really have input handler and output handler functions. Yeah, it's the callbacks, right, that help a lot in this case. Yeah. So I ran it, but it didn't work because I have an output handler here that says it's not callable. Is that because I need to run it in a different order? It would be very strange, I think. But maybe that is the case. And I don't have a shortcut for moving statements up that I like. I will use Control Command Up. This. And why is my output handler not callable? And G, you're gonna take a nap again. Oh yeah, I see, G, that you haven't finished part 1 yet. Well, if you're tired, of course, do have a nap. Or the other alternative, which I recommend, I didn't do it today, is to do about 20 push-ups if you can, or a few squats until you feel like your legs are heating up. That will definitely wake you up. And what is the matter here? Instance attribute defined outside init. Okay, so we can define our NICs first. But why can't I specify a method as an output handler? So I'm trying here to set... Oh, wait a second. I shouldn't call it. I should assign it, huh? I don't have a assignment function for that. So we do get some errors. Error 10. Okay. Why is that? Let's turn on debug mode. Do I actually pass -1? Yeah, I do. We all rely on coffee in some way. I see a lot of viewers coming in today. Maybe that's because the Intcode computer programs are not for everyone, and we decide to just take a chill and look at what other people are doing instead. In any case, welcome everyone on the stream. We're doing day 23 of Advent of Code, trying to hook up 50 VMs together that are going to handle network traffic. And I think I do have to specify which address every one of them is. I think I need to send all of them one value. Be sure to assign an address to each of them via a single input instruction, right? So that means that its address is I store it also here. And so the first time we boot, we do have to specify an input. So computer input 1, and when I run a program, I don't clear the input. I'm confused about that. So we do input not just a 1, but the address. Now it can run a bit more, and the pen takes only one argument. Yes, that is what we know. And the buffer is the receive buffer, right? Let's rename it input buffer. And from the input buffer, we can, let's see how the input buffer works. We receive is called directly by the NIC that is sending, and then when we are receiving, all we're doing is appending it to the input buffer. Maybe that's not really logical. I think. Oh yeah, here we're actually doing the handling. Okay. Well, let's run it. It keeps running, so that's good. No more crashes. I'm going to turn off debugging. And well, that's it. It's running now, and I have no idea how long it's going to take. I think my code is probably not wildly efficient. Do I have a way to handle if it's done? Yeah, if it's not waiting for input, then we'll break. Maybe I'll do a little bit of logging here. So let's say let's say that we send code somewhere. So maybe where? Here. So we're sending X and Y to some destination. X, Y, and destination. So we're sending huge numbers actually. And at some point it just stops. And how can that be? Is it really not running anymore? Okay, receiving -1. Receiving -1. Oh, I know what to do. So when we receive our 3 inputs, that doesn't mean that we're done and we have to clear our output, right? Or let's say it this way, if we have 3 outputs, that's great and all, but that means we should not clear all the output. What we should do instead is pop. So we'll pop 3 times. So destination is the output buffer. And we'll pop the first item. And so on. We'll pop the first 3 items. And then run it again. Pop index out of range. Oh wait, we should pop always this first item. And I think now it's just running forever with -1. And I think the problem is with my system that input and output handling is not really synchronous. Hey Yamabushi, thanks for following. Welcome on the stream. So what my VM is doing actually, it is running forever until it needs input, and then it will just break. So our execution loop is like this. It is a forever loop. And then at some point there's waiting for input. So if we don't have any inputs and we are waiting for input, then we're just going to halt and set waiting for input on true. Some people have set this up using handlers, and I think that might be a little bit easier to do. So instead of halting, we'll just set up a handler. Maybe that is the reason why it keeps on going. Input received -1. So it looks like all the computers are receiving the same input, receiving -1 all the time. And we can pass a name to it. Maybe we should pass a name to it. To the computer, that is. So we'll instantiate a program here, and the first argument is the name. Actually, I see that it is computer 0 that is waiting for input all the time. And so computer 2 and 3 and so on are never running because the first one is always waiting for input. So that's something I have to change. I could use multi-threading, which I have not done before in Python. Well, I am not very experienced with multi-threading anyway. So generators, I think, are really the best thing to do here. But that means that I do have to change my int code computer a bit. So what I could do is, for example, have an input generator like this that I pass as an input, which is none by default, and I'll save it also like this. And what it will do is when it's trying to receive input in the execution loop, so here we're checking for input, and if we don't have any input, then let's see. If we don't have any input and we don't have a receiver, or let's say if we have a receiver, so input generator, then we can do something, and otherwise we'll check the input buffer. Maybe like this. So then we'll just get the next item from the self input generator. So that thing should yield us some values. And the input value is going to be this. Okay. I feel like I do need to test this though, because I'm changing quite a bit of logic here. Maybe I'll make a little test here. Let's see. Can I just make a test? Just making a Python file here. And I'll call it computer generator tests. And that extends from unit test, I think. No. Let's see how I did that. Here I'm importing unit test, and I'm using it like this. Unit test.test case. Okay. And our first function that will test is what happens when you're passing just a single input to a computer. Print single input. So our VM is like a computer. Int code computer day 9. And input generator is going to be a generator, which I'll define here. And a generator is defined by the fact that it has a yield. And maybe I shouldn't call it input. Maybe in, or stream in, like this. And we want to run a program, and the program is going to be a list of int codes. And let's say that we first take an input, that is all. So we have an instruction set somewhere. We have input, and we're going to write that in, oh, how was it again? Let's see how I used this function before. Oh yeah. So the input is going to write the input somewhere. We haven't actually programmed our int code computers for quite some time, so it takes a bit of thinking to figure out how it works again. But we first have an input instruction and then an address to store the input. Like let's say address 99, no, not 99. Maybe address 42. And after that, we're going to output that address. And the mode for that address that we're going to provide afterwards is going to be a position. Modes, I think I called it. So it's a position. And after that, we'll halt. Like this. And can we actually import that in a bit of a quicker way? No, apparently not. Well, we'll keep it like this then. So these are our instructions. And then let's assert that we have an output. The VM's output is going to be exactly the same as whatever we input into it. And that is going to be the number 7. And the input generator, maybe that receives a list or something that we can actually pop from and append to. Input buffer, like this, input buffer. If we have an input buffer, then we're going to yield the first item. I'm not sure. Hey Anagon, I don't know if you saw my PM, but I got day 7 solved. That thing was a satisfying pain. Oh, I'm sorry, userman. I haven't checked my DMs actually. I do need to set up notifications for that, I suppose. Day 7. Can you remind me again which day that was? Is it with the amps? Yeah, it's with the amps. Oh yeah, wow. Okay, that's a good preparation for today then. Because I think if you have done day 7, then you can actually continue on day 23. So we're yielding the input buffer. You know what? I'm actually not entirely sure if this way of working is going to be very helpful. Because it seems like now I'm just implementing a bunch of logic in here, which I could have also implemented in the VM. But yeah, then I would override the VM's internal logic and putting domain logic into the VM itself. Yep, that's right. In day 7, you don't need to build anything new, really. You just need to make sure it's flexible enough for that particular case. So let's start with inputs. And if we don't have an input buffer, we're going to yield -1, right? But only if we are requesting. That is kind of strange. Oh yeah, okay, so let's say that, yeah, we are going to be in a loop. Maybe that is what works. And so if we have something in the input buffer, yeah, while we're in the input buffer, then we're going to yield. Otherwise, we're going to yield -1. But we need to make sure we don't end our stream. We should be able to stream forever. Well, true. Like this, for example. Maybe. Maybe just like this. But this would yield like a value and then -1 and then a value and then -1. That's not what we want. So maybe like this. And your spaghetti is pretty flexible. That's nice. Okay, so there we have our streaming generator. Oh man, I hope it's gonna work. And now we want that if we are passing 7 into the inputs, so that's what our input generator is going to start with, then the VM should return 7 as an output. And right now it's still using the original input method, and yield is not going to be used. But now I want to change it. My instruction set class is just a wrapper for generating the different operations that you can do. So I have add, for example, and you can pass it a few modes. Then it's going to generate the instruction code for that. Alright, so now we're going to look inside our intcode computer and make sure that it's handling data from the input generator. Oh, well, we do have something like that. Maybe it works. Maybe it actually works. So yeah, it's running there, and that works. So that means we're no longer needing to start and stop our computer whenever there is input needed and when input is received. So if we are passing to input and we do have an input generator, then actually we want to send that input to the generator itself. Maybe we can do that. So if we have an input generator, then we're going to yield. No, how does it work? So sending to the generator, how was that again? There is a way to do that. It was self.inputGenerator.send, I think. Maybe we can type annotated. I've never done that also. Generator, generator, generator exit. Is generator not a type? I never use type annotations. Haven't done that yet. Typing. Let's see. Should I type typing? Accept that stuff. Yeah, I was doing that. I was doing generator and then suggesting collections ABC underscore generator. Not so sure. Oh well, I know what to do. We can use the Python console for this. So let's say we have a function foo that yields 1, and then we'll run foo, and then we'll say type of x, and it says generator. Okay. Import this name. Cannot find reference typing. Generator. Maybe generator works. Collections.generator. Can we see if the type equals collections.generator? Then we need to import collections.generator first, or maybe collections. It has no attribute. Generator. Python type int generator. Okay. You need to import the typing. Oh, it's with a capital G. Ah, you see. Right, okay, so that means that here we need to use a capital. And we cannot find it anywhere, but here maybe. Yeah, there we go. Alright, thanks userman. So now we can actually send to our computer in day 5 when we receive input. So do we get a good type hint now? Yeah. PyCharm by default filters by first letter, gets in the way of Control Alt Space input search. No, but if you press another time, I think it works. Oops, I think I just ran it by accident. So let's say I'm trying to import a default dict. Let's say, okay, but how would it matter if I would start with the first letter anyway? And if I do control space again, it usually does search a little bit more than otherwise. So I think you don't need to change your settings, but I'm not sure. So we'll do send, and to receive that value, we do need to actually read it. So our if it's about capitals. Oh yeah, okay. I do like the capital sensitivity because then you can search for the first letters like I, C, C, D. Then you can just autocomplete your encode computer. Not sure what would happen if the capital sensitivity was turned off. Okay, so our handler is written where exactly? I lost it. So we have our nick and we have our input handler. Wow, completely lost it. Did I delete it? We have an output handler, we have input, and oh wait, I was doing a test. Excuse me for that. So we need to sometimes we need to send data to our generator, and by now I was using input buffer. Yeah, I'm not entirely sure how I'm going to set this up, so let me draw it actually. So we have a VM and we have another VM, and this one needs to have some kind of function that allows it to receive input, and right now that is called input. Now the VM sometimes needs input, and when it needs input, it needs some kind of way to get input, but I think we cannot do both approaches. So we cannot have a generator like here where we say, okay, if you need input, just take it from there, and then at the same time when we want to send input to the VM, that we're going to use this input function, because then how are we gonna link them up? Because input is just a method on the VM and it doesn't know that this generator, wait, maybe we can actually send it to the generator. Maybe that is fair, because we did specify that this input handler should be a generator. So we can just say, okay, we receive something and we append it to the generator, right? Maybe like that. And I think still what we're doing is probably overcomplicating things, and that is not a good sign. It's still going to work and it's fine, and you might say, well, when it works, it is all right. But you write a lot more code and you have a lot more concepts, and the more concepts and code, the more chance of bugs and the harder it is to maintain. So I do like simple solutions much more than solutions, yeah, which are very complicated. So what could we do? The simplest way to let our VM receive a single value if there is no input, that would be to to actually set a default input value on our VM. That is a bit lame, I would say. So let's say that the VM always has -1 if it needs an input and it doesn't have one. That is kind of the same as having a generator that always outputs -1 and taking output from there in case you don't have any input. Maybe that's what we can do. Okay, so actually, so my encode computer does not use callbacks. At least it doesn't for the input. For the output it does. So that's what I'm going to do. I'm going to make default input generator that always yields -1 forever. And I'm going to set that as a generator here, like that. And so our computer will work like this. If it is waiting for input, this part about the generator I don't use. So where is it waiting for input? That is here. No, here. So if we don't have input, then we're going to try to get it from the generator. Like this. If we have a generator, and otherwise we'll really halt the machine. So we have some debug, like we can do print. Taking input from generator, so that would be -1. Yeah, but the computer doesn't know that, so it's not too bad to do it this way, maybe. So I'm going to adapt the test to see that if we pass one input, but we are asking for 2 of them, then we'll get first the passed input and then just -1. And you're not sure what stuff you need later, so you basically made a whole set of class callbacks. I think that is a good approach. That is a good approach because you're going to have to hook up this computer in different ways. But so far I've been doing pretty fine without any callbacks. Just loops, and that's it. Alright, now we should actually get output that is 7 and then -1. Yeah, let's run it. I think this one, oh, it works. Cool. Before I wasn't able to run a single program for some reason. Please use assert equal. Okay, let's do that. Program ended, and our debug statement doesn't print the name. Taking input from generator. And let's also print the input that we receive. So it took -1 both times actually. Ah, but wait a second. If we have no inputs, then we do this. But what if we do have inputs? Don't we pop at all? Ah, I know why. Because I'm not inputting that value actually into the computer. So we should actually tell our computer that we're going to input something, which is 7. And then we'll do -1 by default. So it ended and our tests failed, they say. We expected -1, -1, so that means that this is reversed. We should first show the expected output and then the actual output. And we say that we are getting -1, -1 in fact, even though I'm telling the computer that we have some input. And when that happens, we append it. And we were not waiting for input yet, so the execution loop should not be activated. And here are all of our opcodes, and here is the input. So we shouldn't end up in here, right? Because if we have inputs, let me just clean that up a little bit. If we have, oh wait, if we don't have inputs, then we end up doing this, and otherwise we'll just pop. So do we get here or not? Seems like not. So let's see how that goes. So inputs is empty. So do we actually reset our input when we run our code? When we run our program, Oh, my fingers are shifted on the keyboard, so that's why I'm hitting all the wrong buttons. So we run the program, and when we load the program, we reset. This is always messing everything up. So we cannot actually provide input and then run a specific program. So we should do it like this. Equals like that. Now we get a green test. Alright. So now we know that this works. So we are going to pass to every NIC a generator. Computer.input generator is always -1. But let's say default input yield -1 forever while true. And that is the default input generator. And that's it. Maybe we can already run it. A lot of output, and it says that that system 0 is taking -1 from the generator all the time. And I think we still might have a loop here, yeah, where we pass -1, so we don't need that. So if it's waiting for input, then we just can pop from the input buffer. And why is computer 2 not starting? Is that because it's running forever? I think it is running forever. So because it is running forever, all the other computers never ever start. So I think that even though we're supposed to kind of run them in parallel, or we should never stop executing, we do want our computers to actually be able to run side by side. Oh, that's early morning again. And I'm thinking, well, breaking the execution loop was very helpful. Because what I could do at that point is just breaking the execution and then start with the next computer until that one is waiting, and then run the other one. But I think if we do that, we might get a different outcome because of different timing issues. So maybe we should run them in parallel, but that means also that I'm not sure if we're gonna have like threading issues. Hey G, you woke up again? Okay, you need to sleep a bit more on it and learn how to run things in parallel. Alright, well, I'm going to learn that right now. I think we've looked at an example. We have looked at an example with parallel code, and I might have saved it still. Thread. No, I don't have any code in my repository with threading in it. Multi-thread. I think it's not gonna be that hard because I saw it. It's just importing a bunch of things. The fact that all the computers here are non-blocking helps, yes. Well, does it? In the way I implemented it before, it wouldn't matter much because they would just wait, and as soon as input comes in, they would just kind of kickstart again. Hey Arcanian, by the way, good morning, or good evening rather for you. I see that you finished and the stars are not working again. I'm very sorry about that because I like the stars and I guess you do too. So here is a star demo to reset the system. It's going to be a little bit overloading the sound system. There we go. So consider that your star, Arcanian. It's very hard to build something reliable actually with HTML and videos that works in OBS consistently. Python 3 multi-threaded. So what we need to do is import _thread. Why is it called _thread? Is it like beta or something? I'm not sure if this is reliable. Python 3 threading. Some examples, threading.local. Yeah, exactly. It looks a bit shady. From threading import thread. Okay, and then what? Condition objects. I don't want to create logs like right away. I just want to run a thread. I must kind of express my anger a little bit on the Python documentation. They always give you a whole bunch of methods that are available in a module. They don't actually give you a simple example. Thread target is func and then start. Thank you very much, userman. That is what I'm going to use. Maybe we can all build together a new Python documentation that is more handy. So we have our functions, and those are going to be the nick boot functions. But I think I need to make a lambda for that. Like, let's say boot nick. But hold on. Ah, yeah, okay. I think I just need to do a loop and then run something like boot nick. And then pass that one. I hope. I hope that works. And then we have to somehow wait also, right? There is a barrier. And each of the thread tries to pass the barrier by calling wait, the wait method, and will block until all of the threads have made their wait calls. So how does that work? You do b.wait. Okay. Oh, and there's a count to it. Ah, I see. DevDocs is nicer than pies. Okay. Let's open that one. But isn't it just like a aggregation site for all things in the world? Oh yeah, I've seen this one. Yeah. And then you can also store it offline and stuff. And then I should be able to search also in here, right? Threading.thread. Yeah, this is still kind of the same as the other one, but just a better visualization. So barrier from threading. And let's say that we're going to wait for 50 of them. Wait. Well, okay, we'll call it B then, whatever. And when it's done, it's going to wait for the other ones or something? Maybe? Is that what I want to do? No. What I kind of want to make sure of is that we stop at some point, but I have no way to stop. But what I can do is waiting for all of the nicks to be initialized. Nah, it doesn't matter. No barrier, no barrier. Let's just run this and see where it goes. So everything is running now. And probably I'm raising an exception when there's an input sent to 255. But I think because of multi-threading, we'll actually just keep going. So I'm not sure if this is the right way to do it. But let's turn debug off for now. So at least at first sight, it seems to kind of work. You do get kind of different machines getting inputs. And, well, why do I have so little output now suddenly? I don't know. Let's have a look. I see actually all of them are getting -1s. Maybe even from the very start. I'm not sure. Is it because I'm not handling the output in such a way that we can send it to a computer right away? So taking input from a generator, and do I log when I'm taking output? So here is when we receive something. We're appending. Okay, and when we have exactly 3, then we're gonna pop. Okay. But yeah, that could be that it is not thread safe because we are appending and popping at the same time. So that could definitely be wrong. Outputting value. Outputting with 2 T's, not sure. Value. Maybe I'll also print the name of the machine. That is a self.address. And let's see if we output anything at all. Okay, I don't see that happening. Oh, right, I remember. We need to pass it also one input, which is the address. And in boot, I do that. I do actually do that. And yeah, DQ is better for left popping, I know, but I think performance is not really the problem I'm having at the moment. So when we run it, we do actually see some things happening. Okay. So we have some outputs, and when we're outputting, how does that work again? Ah, when we're outputting the address, right? And the X and the Y. So here, basically, we're saying to 7 send these 2 numbers, okay. And does 7 ever receive anything? So, no regex, please. Yes, 7 does exist, but it takes -1 mostly. And then I don't see anything else. So what I'm going to do is, this is maybe a bit weird, but the default generator, I want it to sleep. I want it to sleep for like 1 second or something. So that it doesn't kind of go on forever and ever. So we're sending a bunch of things, and then when do we actually send something to something? Here. And I'm going to add the name of my computer here also. Self.address. And let's say we received something. No, we're sending in this case. Okay, so all of our print statements now have a name. Did you do all 22 with 2 stars? Mr. 3AD says. No, unfortunately not. I did get pretty far, so you can see that I've solved most of them with 2 stars, but I'm missing yesterday's part 2, day 18, the whole day. And that doesn't mean I didn't work on it. I've worked on it for 10 hours or so, but I didn't manage to solve it yet. And 16 part 2, I've also missed. 16 is the one with the FFT, with the huge list of numbers that we need to kind of iterate on. And the similar problem was yesterday, shuffling a big list of cards. So big number games are really not my specialty. And you, Mr. 3AD, how did you do? Did you solve most of the puzzles so far? So I was waiting actually every time that we're receiving some input and then running it for a short amount of time to see that it is working the way I think it should. Most but not all. Yeah. 34 stars in total. Oh yeah. Well, that's pretty good actually. That's most of them. Yeah. So we're sending now. Where are we sending? I want to see that we're sending something. So 43 should be the first one to receive anything. And it is taking an input. Doesn't work. Okay. Maybe I would also like to wait a little bit before yielding. Let's sleep like half a second like this. Yeah, just before. So let's do it again. Let's look again. Now we are sending to 14 first, so it's very unpredictable, which is logical. But what I could do is to sleep a little bit so that every NIC is booted in the right order. So let's sleep for the NIC its address, which starts with 0. Let's sleep 100 milliseconds at least, and then per NIC will sleep 100 milliseconds. So I'm kind of making it sequential. Generator already generating. Oh, am I calling the generator twice? It's trying to do a lock. And that is a very strange error, and it happened when I started to sleep. If I don't sleep, we don't have this problem. Huh. Why is that? Maybe I'll do this break thingy, actually. See if that helps. I have no idea what I'm doing now. Generator already executing. Is anyone familiar with that? It sounds like I am... Wait, if you call a generator twice, then you should actually make a new generator. So you can't really execute a generator twice, right? Or am I booting the same NIC instead of different NICs? No. Maybe I can do thread but sleep or something. Maybe let's look about that. Python sleep thread. Time.sleep blocks the thread. Okay. So we can make a thread, a worker that runs, and it has time.sleep, and that should actually work. Okay. So why can't I sleep in my thread and then boot my NIC? Why can't I? Am I sending anything to my generator? I don't think I am. Nope. Then it did not finish and it did not return next, asking for next, while it did not return will error. Oh, with error, I suppose. Oh, it didn't, and asking for next while it did not. Does it mean that I should return something in the end or something? Or maybe it's because I'm doing sleep and then sleep, so we have two sleeps in a row. Maybe that is something that we shouldn't be doing. What if I remove this sleep here? Yeah, then we don't get that exception. So kind of sleeping twice is not so much liked by Python. I'm not sure why. And I saw an exception here also. An exception was occurring here on a certain line in a log acquire. Okay. So maybe what else can we do? Maybe the sleep that I put here was a good idea, but it's not big enough. Maybe let's sleep 500 and wait. If you had started for Oh, sorry, Mr. 380. I missed a bunch of your messages. You really like int code stuff. Yeah, me too. You've known about Advent of Code for years, but you're always too bored to try. Too bored to try? Well, this is something that keeps me from not being bored, I would say. Although I do have always something to work on. But Advent of Code has been fun for me so far. And you wish you started 20 minutes earlier, probably your last chance to get into the top 100. I don't know. Depends. Some people can solve this puzzle in a few minutes. And how is our current day doing? Yeah, okay. Oh, wow. Day 9 still has only 92 people who didn't finish part 2. But yeah, because everyone finishes part 2 basically. Yeah. Ah, yeah. I see. Yeah, you don't get any points for solving part 2 or part 1, I think. I'm not sure if you get points for solving part 1 in the global leaderboard. Maybe you do. Okay, so I'm sleeping and that doesn't work. Maybe we should. I'm not sure. Oh, you get points for both independently. Cool. Yeah, as a person with experience, you can tell us that. Because you have been on the leaderboard, I think. So this doesn't work. Each of those start, you were looking. Oh, nope. Oh, you haven't been on the leaderboard. Ah, sorry, man. Sorry for saying that wrong. Yeah, each of those stars represents a couple of thousand users. Yeah. And your best position is 104. Well, that is pretty close. But yeah, those 10 seconds can definitely kind of kick you off of the top list. So once it is taking input from the generator, it is sleeping. Maybe I can sleep inside the machine instead of inside of the generator. I'm not sure if that would make it better. So here somewhere we're waiting for input, taking input from generator and then sleeping also. Let's sleep just a tiny bit. Or maybe not. Let's sleep like a whole second. So why does it start with 49? That makes no sense. That really makes no sense because I'm booting all of them in order and I'm actually sleeping more for the higher nicks. Maybe that's because... Okay, maybe I'm actually not running the nicks in the order that I think I am. Booting... I'm booting Nick. And G! Good job and good job not falling asleep. You solved part 1. Nick.address. Okay, so we're booting them in the right order. You see? My neck is hurting a little bit. So it's booting and then it's running, but then the first thing that is doing anything is Nick 49. Is that maybe because Eric has made it in such a way that Nick 49 is the first thing to do anything? Or maybe the other ones are actually executing and the last one, 49, doesn't have to calculate a lot of things and it would just start by taking input. Maybe that's what happens. So let's increase the delay, but no. Now it's running only 49 and not anything else. What is happening to our other nicks? You have read the documentation, even if you were sleepy. I'm so confused about this. Like, why does this sleeping completely change everything? If I don't sleep, it seems to run all the different nicks really fine. As you can see, it's running nick 8 and 4 and taking inputs here and there, and it's sending. But when I sleep in my thread, just a tiny bit, doesn't work. It's booting all the nicks and then only 49 is working. Oh, maybe it's because the other ones are all kind of dependent on each other. Here I'm waiting also 1 second. Maybe that is making it a bit bad. But no. There's some kind of black magic going on here. And maybe it has to do with multi-threading in general. That things just don't work the same way as you're expecting them. Because if I'm not using thread safe objects. So let's not sleep then, I guess. Any hint would be appreciated. Why is my code behaving so weirdly? And so I did see an exception, and I hoped that it would be an exception about sending to address 255, but I know it's not. What does the parameter in sleep do? Is it the time it's sleeping in minutes? No, in seconds. Right? Should be in seconds, not minutes. Yeah, seconds. And GIL is your thread safety. GIL, what does that mean? Python. Global interpreter lock. Okay. Oh. It's a mutex that protects access to Python objects by preventing multiple threads from executing bytecodes at once. Ah, so it's actually single-threaded. Does it mean it's single-threaded and it's just switching threads? Oh, okay, so you won't make it any faster even. I see. Okay. But then why do I get the threading lock error? You need to use multiple processes. I see. That's why Python threading is so simple, so to say, because it doesn't actually multi-thread. It just switches stacks and contexts. And so we do have locks apparently here, and we do get exceptions there. So it's trying to acquire a lock and we get an exception from it. But the global interpreter lock is on forever by default, right? Because you have to make an effort to get rid of it. It's not like you have to add it to your code. Well, maybe I won't sleep then. I don't know. This sleep is messing up my execution. And now we will see that things are not running as I wanted. And I do get so much output at the same time. So Nick 1 is outputting a bunch of things. It starts by taking some inputs. And it's outputting 14, then another number. Is it outputting the third number also? Let's look at what 1 is doing. Yeah, it's outputting 3 things. 14, a big number, and then another big number. And so the first one is where it's sending, and it's sending to number 14. And that one is taking input from a generator over and over. So that means that we're sending, but actually it doesn't get sent to the computer. So where are we sending? Output buffer. So we are doing receive on the destination NIC, and that one has self.inputBuffer.append, and here we're running the computer forever until we're done. And okay, we are now using a generator with default values, so it means that this loop is never going to end. So this doesn't help at all. We can just run our program, that's it. And we do need to pass data into our computer directly on the moment that we have received enough. So here we're appending to the input buffer, and I think we don't need an input buffer even. We can just append it right away here. But we should input only X and Y, nothing else. Yeah. People have been making an effort to remove the global interpreter lock for like 20 years unsuccessfully. Because of GIL Python code, Python code is never running in parallel. However, you can block on I/O in parallel and run C code in parallel. Okay, so as long as you run C code, basically run something outside of Python, then you can be in parallel. Well, the good thing about this input handler is that we don't have a loop anymore. And now, a lot of things are happening. Let me just run it very shortly. And we are outputting a bunch of things to number 14. And 14 is taking from the generator only. Even though we have now said that we are receiving, I will actually print that. I think I removed that by accident. Receiving X and Y, like this. And here we're saying that we're sending, okay. And we have some exceptions. So we're never receiving anything. Because we have an exception. Like this. That's the bad thing about threads, that you don't really notice when stuff breaks. And they run so fast that you can't stop your output on time. So outputting to 14, taking input. Okay, so here's actually the point where we're booting the NIC. So of course it doesn't have input yet, I suppose. And maybe. Skills King 46, you're saying, lol, do you even code? I guess you're talking to me. And sorry if this is frustrating to watch. I am a bit sleepy also, because I woke up at 5 o'clock in the morning. Your time zone might be a little bit different. But yeah, I do code, and I solved most of the puzzles so far. Okay, you're laughing at me. Alright, well, jokes don't really come across, of course, over the internet, as you might know. So do be careful. Let's see. Now I lost my track a little bit. So I noticed that 14 was booting quite late, which is fine. So I'm working on Advent of Code. Advent of Code is a daily puzzle event. It goes from December 1st till day 25. And every day we get some puzzles, and today is day 23, and we have earlier on implemented a virtual machine that can handle sort of bytecode. Well, we call it int code. It's like a long sequence of integers that represent instructions. And today we're going to hook up 50 of those VMs together, and that should run a program. This program is provided to us by the puzzle, and it looks like this. And of course, you're not supposed to read that. You should pass it into your computer, and the computer will read it. And this is the first time we have to run these VMs in parallel, and I'm using multi-threading to do that. And multi-threading is something new for me, and I am kind of struggling to see what it's doing and see if we are doing it right. And I think I just fixed a bug. And I'm in college or graduated? No, I am a professional developer, and I have learned most of programming skills myself, although I did have a few classes in computer science. And now I'm a bit lost. Let me run it again. So, oh, we're actually receiving. I do not code Python at work. I actually don't code a whole lot at work at the moment. I'm in a project where we are maintaining a legacy application and mostly doing operations. So I'm mostly looking at network problems and looking at like web server logs and trying to fix those sort of things and SSL certificates and such. But before that, I was in a project where I was doing Java mostly. And previously, I was doing also Kotlin and PHP. And Python I have done mostly for fun outside of work. And Skills King, you're going to college next year and you're trying to get ahead of by self-studying higher level math, and you want to get into machine learning AI. Oh, that's cool. I did study AI, and AI is a lot of fun, especially nowadays, because nowadays you can actually use it and it works. And when I was studying it, the message was mostly that, yeah, these are all the kind of formal methods that people have invented, but actually we found out that they don't work. But yeah, now it's 10 years later, and those techniques have advanced far enough to actually be helpful in a lot of new domains. So 14 is finally receiving some input, and the other NICs are booting, and we are getting output from them also. Now it seems like we actually have some living system, and when we are done, we want to kind of quit. We want to quit the whole thing, and I see an exception here, but that is also a threading log, threading exception problem. I don't know why that happens. Maybe it's time now to introduce again to our generator this little sleep function so that it won't go too crazy on the inputs. But then we see that all of them receive -1 only. And here is again this weird thing, generator already executing. So we cannot sleep in a generator. Maybe that is the whole point. Python sleep in generator. Using generators to sleep without blocking? Okay. Do we get some nice suggestion here? Nope. Let me sleep again inside the computer here. I think that is our best chance. Yeah, we don't crash. That is a good thing. So let's sleep for 1 second. Let's just sleep 1 second after taking a -1 from the generator. So there we go. Now all of them return -1. And there might have been an exception where we actually received 255, which should kind of end our program. And instead I'll just do system exit, because that is the way to kill all of the threads. Yeah, I did day 7 without threading. I have not used threading at all in Python, like ever. So that's why it's a bit of a mess right now. And I want to show that we're sending some number like this, x and y. Oh, and actually, I do see that my formatting is wrong. So maybe that's why we got an exception also. So a lot of things are running. And you did not use threading for this one either. Maybe I didn't need to do that then. Yeah, I guess I could solve it the same way as I solved day 7. Yeah, I understand. So what I did in day 7 is just run the first computer until it needs input, then run the second computer and pass input to the first one if necessary. But there was so much emphasis in this puzzle that you have to keep going if you don't receive anything, and there's this case of -1, but well, if you don't have any input for the computer, then you do need to pass it -1, right? So I'm not sure if, do you actually use -1 at all? Because if you don't, then I think the instructions are a bit misleading. Okay, you do use that. You can just send -1 over and over again until you have something to send it. Are you talking about the case where you do use threading or where you don't use threading? Because if you don't use threading and you keep sending -1, then you'll never send it anything because your other NICs are not running, right? Because if you're in the loop for one particular VM and you're just running the execution loop, I could send it like 50 -1s so that it, in case it needs any input from any of the other machines that I need to run, it can wait for those. I use callbacks and the callbacks just return -1. It's only called when the input queue is empty. Yeah, that's kind of what I'm having now. You switch which one you're running every time one of them outputs something or requests an input. Yeah, that's kind of how I solved day 7 also. Okay, let's do that. It shouldn't be a very big change. So we have our NICs and we have our loop where we run them. And we don't use, let's say we don't use a generator. Well, okay, we do have a generator, which works fine. And we're going to boot all of the NICs. And the booting code, that is what is going to handle the loop. So while true, and if we're waiting for input, and you're saying you're also breaking when you're getting output. That's interesting. So we could do an output handler for that. Yeah. My code does not allow me to break when I have output, actually. But maybe that is not necessary. I just need to make sure that we have an output handler that works. The output handler is doing a lot of crazy things. It's appending, and then when it has 3 items, it's going to pop those 3. Check if we are sending to 255. Otherwise, we're telling receive on the other NIC. And right, okay. And I think here might be the problem that if I say input X, then the computer is going to run right away, and then it's going to want to ask another input, but that input will be provided only after this piece is completed, which is fine, because I think it will actually halt. But in my case, it's going to use the generator and it will get -1. So it will receive only one single input, and then it will never stop. Unless I could somehow append 2 values to the inputs and then run the computer. That would be handy. So do I have another function called input with multiple inputs? No, I don't. But I could, maybe I'll just call it values here, and I'm going to extend it with the values, like that. Inputs received. So that will be a list. And, oh, hold on, that was the name of the computer. And where do I use this function? It is here. So we're going to input X and Y. Maybe that works. And then we'll just use the threading as we did before. Do I still have my input generator? Yes, I do. But that didn't work. This is not iterable. Int object is not iterable. Ah yeah, because actually it's a list and I can just pass it like this. So something is happening. And how does it look at first? You take some -1s, all of them are booting. And then actually one is outputting something. And it's sending to... Oh, the output looks in the wrong order, actually. Oh yeah, it's outputting to 14. And it's receiving something. And it's receiving something else. And it's not waiting. So that's a good sign. Okay, maybe we should just keep running it. And I'll override the sleep to be a little bit less sleepy. Let's sleep 1/10 of a second. And now we see actually that all of the generators are receiving -1s. So they're not outputting anything anymore. So maybe it is still broken. Okay. Time to do what? Time to not use threads. Booting all of the NICs. And while we boot them, maybe we can... Hey, XBitQbit, welcome on the stream. Thank you for following. I hope that the next few days are going to be a little bit more fast-paced, because today I am going quite a bit slow. But what I just decided to do is to not boot the NICs. I'm just gonna handle the VMs in the NICs directly. I think that is, of course, breaking encapsulation. So it is not a good idea in general to do such a thing. But I'm not entirely sure how I can handle... yeah, what I can do is actually create something like continue. Or maybe continue is not allowed, so what word can we use instead of continue? Go. Let's just call it go. So we run the program, and when we need to keep going, we just do like run program, or we do execution loop, like that. So when we run the program and we are done, then and we won't have any input generator. So I don't want an input generator now. So here we're going to boot all of them, and then we're going to go over all of the NICs again. And then if the NIC is waiting for input, Okay, you know what? I'm just going to go inside the computer and check if it's waiting for input. And if it is waiting for input, then we're going to pass it -1. So we're going to input -1. And otherwise, we'll just keep going with the next one. Go. Not sure if that's going to work, but we'll see. And to boot, you need all the other NICs. And here we have an exception. Oh, that means it's working. Okay, 1, 2, and 3. And okay, I pasted some code inside my string, my formatting code inside my string. So now we have something that works, right? Yeah. Okay, so the threading really made it very difficult. And what I'm doing now is just using a loop, and that works very straightforward. There we go. Sometimes it's valuable to you know, try hard and learn something new, and sometimes it just gets you stuck very long. Could have solved it in just a few minutes, not using threads. Okay. I'm going to commit date 23. But it does tell me that I should practice doing threads on a more simpler case, so I understand how they really work. Part 1 solved. Thank you everyone for your congratulations and for staying on the stream while I struggle. So the first half is complete. Now what do we do? Are they going to ask us to do threads? Packets sent to address 255 are handled by a device called a NAT. Not always transmitting. That is a pun, of course, because NAT means Network Address Translation. A NAT is responsible for managing power consumption of the network by blocking certain packets and watching for idle periods in the computers. Okay. If a packet would be sent to address 255, the NAT receives it instead. Okay. And we do have an output handler. So actually, in the output handler, that is where we could detect it. But so this is our NIC. Okay, let's see. The NAT receives it instead, and the NAT remembers only the last packet it receives. That is, the data in each packet it receives overwrites the packet's memory with the new packet's X and Y value. Okay. The NAT also monitors all computers on the network. If all computers have empty incoming packet queues and are continuously trying to receive packets without sending packets, the network is considered idle. Once the network is idle, the NAT sends only the last packet it received to address 0. This will cause the computers on the network to resume activity. This way, the NAT can throttle power consumption of the network when the chip needs power in other areas. Wow. Monitor packets released to the computer at address 0 by the NAT. What is the first Y value delivered by the NAT to the computer at address 0 twice in a row? Wow. Okay. That is a bit confusing and complicated. So let's see if we can draw it out. And Valerie, you're saying at part 2 your answer was actually second Y delivered twice. You mean the second Y that was sent was delivered twice? So you had to iterate only like two times? That is unexpected. I would expect this to run a long time, but maybe we don't have to do that. So we have our VMs here all lined up, and they can send messages to each other however they like. But there's one type of message that goes to 255, and that goes to our NAT. And that one always overrides it into a kind of memory address over and over. And then it also monitors all of the other computers. So I'm not sure how this is related to the NAT, but let's see that all of them are kind of receiving -1. They're all waiting. Then we are going to send a 0 to the first computer, right? That is actually not that complicated. And Alex, you're saying for you the numbers got smaller by less and less, and eventually you got the number twice in a row. So it wasn't the second Y overall. Okay. Interesting to know. Maybe it would help me to figure it out a little bit quicker. And for now you received only one NAT packet ever. Oh. Okay. Yeah, I think for me that is also the case because I'm crashing the whole thing when I receive 255. Okay, so actually, I see. So this is not gonna work, of course, exiting the system. But what I do want to do is I want to have some kind of handler that we can use to kind of deal with this 255. Maybe we can just make a state that says I received 255 and these are the values. Something like that. So that means that NAT message, the message to the NAT is something. It starts out by nothing, and then when we do send to the NAT, then the NAT message is going to be X and Y. That's it. Now we don't need to exit, but we do need to stop, I suppose. Not really. No, we just keep running until we are waiting for input. Okay, so if we're waiting for input, that means also that we're done, but maybe I can just do this one here. And when the NIC is going again, then I want to clear this NAT thingy. Oh. If the nic.NAT has something in it, that means that we're going to store it. Like here. And we need to keep both the X and the Y, or what? Only the Y value? I think only the Y value. So it's a bit funky that all those Y and X values are not used at all, but maybe we can print them and see. Although I would probably not do this because the values are huge, so I'm not sure I could even render that. But I'm curious to know what those X and Y values mean actually. So here we're overriding. You need both because you need to send it to address 0 later. Okay. Well, I'll store both then and see. Yeah, we're actually not sending 0, so I miswrote that. We're not sending 0 to the first computer. We're sending to computer 0. And we're sending it the last values from the NAT, like X and Y, I suppose. So that was a little misunderstanding. When the network is idle, yeah. Okay, so if we're done. Oh, interestingly, I was running the NICs only once. I was not looping this forever, and we should. And so if all of the NICs ran and they were all waiting for input and they didn't have input, so I can check if they didn't have input. Let's see. Well, how can I check this? Because if a NIC has input and it's taking input, then it will just take that and keep going until it needs input. So that's basically this point. I think the NICs always need input. They will never stop. So this case is always true. So basically, if we have run every NIC so far, then we're done, and then we're going to send whatever was in the NAT to the first computer. So the first computer will receive an X and a Y from the NAT, like this. And that's it. And we'll keep going. And then we need to know what's the first Y value delivered by the NAT. Oh yeah, twice in a row. Okay. So to do that, I'll keep a list of those values. So we have the history, and history will be appended with the NAT value. And then if our history contains, okay, so actually it can be a set, we'll add it. And if our history already contains this NAT value, then it means that we have at the point where we received it twice, and we can break like this. Repeated value found. Let's run it. And we get a list index out of range right here. Oh yeah, okay, so when we are sending to 255, we should actually break or return. We should not continue. And here I'm clearing the output buffer. Is that right? No, that is not right. Let's go. And here, receive must be an iterable, not a non-type. Okay, so if not is actually set, then we can do that. And repeat value found, and this is the Y value. And it's correct. Wow, that was kind of easy. All right. Well, thanks for watching, everyone. So we are done with day 23, but that doesn't mean that the stream will end, because all of you have some solutions and they might be fun to look at. Yeah, I think I confused everyone by saying thanks for watching, because I'm not done. If you have a solution and you want to share, please do paste your solution on Jest or GitHub or Pasteboard, and we'll have a look. And the reason why I kind of almost ended my stream is because in the last few days the puzzles have been so hard and so long that it took me hours and hours to finish even part 1, and then most of the time when I was done I had like no energy left to do any code share. But today we're a bit earlier than normal, so now we can do that. See, Alex, you've pasted your link already. Thank you very much. We are going to have a look at that right now. So that is part 2. And let me copy that. And Mr. 3AD, have you also finished? Let me look. You're not on our leaderboard. Well, if you are on our leaderboard, then I can see actually when you finish the puzzle. So I'll share with you the joint code. And that is this one. So if you go on to Advent of Code and sign up for a private leaderboard with this code, then you'll appear on the list on the stream. And now I need to find the right tab. This is AOC 23. It should be this one. Let me go here to the raw data. You joined. And I see that your name is null. Either I have a bug in my JavaScript or your name is actually null. Hold on one second. Fresh coffee being made here. I still have my own coffee. So you're anonymous. Do you want to stay anonymous, or can I rename you to Mr. 3AD on the stream? I see that you finished part 2. Cool. You can rename me. All right, I will do that. Wait a second. This is going to be called Alex. All right, thank you, Alex, for sharing your code. Let's go through it and see how you've solved it. For fun, if I can, I will also run it directly on my system. And part 1 outputs a number and 2 also. Are those the same as I had? Of course they are. I think they're going to be correct. It's 2400 602 and 24,000 and 19,000 641. So yeah, they are the same. And your code consists of a few loops. So you would first read your input and pass it to your VM, make 50 VMs, and you have the last X and last Y. That is probably going to be for part 2. And Mr. 380 says mine are not the same. Oh, maybe you mean not the same stars or not the same code. If you have some code, also please paste it online and let's have a look. So we have a few handlers, one for the NAT, one for the output, and we have an in loop that is a whole bunch of zeros, 50 zeros, and you're going to use that somewhere. Not the same number. Ah, yeah. So every input should have a different output, so we all get different numbers. Yeah. So for every participant of the puzzle will get a different outcome. So we have 50 zeros. I'm curious how that is being used. So you have an output handler where you are receiving input to an address, and if it's 255, then you're calling the onNet function, and otherwise you're going to send to M that particular input, X and Y, and also you're keeping track. You're saying that okay, I know what you're doing. So this list is keeping track of whether or not all of the machines are running. So if you received some input, you're saying, I am actually I'm not in the loop, I'm not waiting. And here, I'm not sure if I should analyze this bottom up or top down. Let's go bottom up. So that means, or top down rather, that should be. So we're going over all of the machines and we're sending it input I. So that means that you send it the address of the machine and you add an output callback. So your machine actually has an option to have multiple output callbacks. That is very handy. And then you're saying get a few outputs. So that is not a generator, but a function that keeps track of how many are stored. And you have local state by returning a function. That is very smart. So you're running a function that has some local state and then defining a new function locally and returning that one. And that way you can actually keep track of some variables without making classes. That's a very interesting way. It reminds me a lot of React. So React has this new kind of state pattern where you don't use any classes, and it also has local state by using locally scoped variables. And you call it a callback factory, and you had created it already on another day. Okay, so you're keeping track of which, and yeah, you did make it another day as well. But I do find it interesting to look at it right now again. So you have to specify non-local. And what does that mean, non-local? Because if you wouldn't say non-local, then what happens? Which has no effect, of course. But here we cannot add to which. So actually, if you define a function that accesses... Oh, it's a function in a function. Maybe that's what went wrong with my computer. Because I had threading going on, which you can't see anymore. But I was referencing the NICs from inside my threading function in my boot NIC function, I called it, I think. And I didn't specify non-local. Maybe I should have done it, I'm not sure. And otherwise it would reference a new local variable inside function. Arcaning, you're explaining that non-local lets you assign to a variable in a parent context, kind of like global, but not limited to the global state. And I see, especially probably when you're doing like which equals, like foobar, you would always override something, even if this is shadowing an outer scope. You would also create a new reference, but maybe it's not the reference that you're trying to keep, but just to specify that you're referencing out of scope. Okay, I do have to practice with that, see what that really does, how it really works. So every time you get an output, you're appending which means that you can keep track of your outs, and then when you have the number that is required, namely 3, then you're going to run the callback and clear your outs. And ints are immutable, so plus equals to an int needs a non-local. So yeah, it does have to do something with references, because I thought that if you have something like a dictionary and you want to play with the dictionary, like setting, or how do you set, like this? This works, right? You don't need to say non-local D. So it's only because of that you are using integers that you need to do this. Yeah. Okay, so it was related to that. Now I understand. Actually, I did have this problem before, and the way I solved it was to actually use the dictionary and store my integer in there, so I could pass a reference. But now this is really a nice helpful trick. So you run the callback with all the outputs. So as you go on programming and learning more and more, things start to make sense as you run into problems and see why those solutions were made. So we were looking here at the loop. So we're adding a callback function, output callback, that takes a few outputs and then runs the on output, which sends the data to another machine and remembers that we're not in the loop anymore. And then we're adding an input callback also, and that is the on input, which is defined here locally. And when there's an input, you're seeing that you are in the loop and you're returning -1. Oh, you're returning -1. How does that work? When you're sending input, does it actually kickstart your machine? No, it doesn't. So when you're sending input, you're just wait, you're not running the machine here yet. You're just adding the callbacks and sending a single input, and you're returning -1. But if this is your input handler, and every time you need input, you're going to run this function, your input callback is called when the machine wants more input than is available. Okay, so it's not run every time. Then it makes sense. So it returns always -1. Yeah. And then what? So we have our loop. It looks like this is for the second part, and the first part is also somewhere. That is on NAT. So when we get an output of 255 and we haven't received a Y value before, then we're printing it. So that was part 1. For part 2, we're doing an infinite loop and another one. And then we're looping over all of the machines. And if we're in loop is less than 2, which I think, why less than 2? Why less than 2? So if it needs an input, then we're saying, it's ugly, but it works. So I know that the machine can take 2 inputs, right? Like, or 3 even. So if it takes 3 inputs, but it didn't get any, it means it got -1 3 times, and it means you kind of want to have 3 inputs. Maybe that's why you're comparing here with 2. Somehow, sometimes the encode program gets -1, but it isn't inside a loop yet. Okay. And so if it does, then you're saying run step, and run step means just run until it halts. Okay. Run until there's no code left. He didn't specify what inside a loop means. He. You're saying he. Okay. I'm not sure what your last remark is about. Oh, Eric. Eric. Didn't specify what in a loop means. Yeah, that is true. I think the instructions for today make it a lot less obvious than it really is. You're just looping until you have no input, and if you have no input, then you're running the next computer. That's all. And I'm not even sure if I'm passing -1 at all. Yeah, I do. But it's not that important. I think it would probably still work even if I didn't pass -1. Not sure. Let's run it. Now it does run forever, and I don't see anything, so maybe we do have to do this. Yeah, okay. But it seems like the -1 is sent like only once or something. It's sent a bunch of times, but that is bigger numbers than -1. Sending -1. Yeah, I'm sending -1 a few times. Okay, quite a few times. But for which machine, actually? Maybe once only, who knows? Oh yeah, and of course in the end, when it's done. So you got your computers running, G, and now you've read the question wrongly. Oh, and you entered 2 answers wrong. You should read it again. Yep. Well, I think you can try as many times as you want, so don't be afraid of being blocked. But you're going to have to wait longer and longer between each attempt. Sending -1. I'm just curious how many times we're actually sending -1. It looks like we're doing it once for each machine. Let's check if that's true. Once for each machine, and then actually we're done. So it looks like a lot of complicated thinking just to kind of send it a -1 once after you're done. Okay. So you're checking if you're in the loop with this variable. And then running. I think I'm still not entirely clear on what this is doing, but you're kind of checking that you're in a loop when you're requiring some inputs, right? And oh, I see. So it didn't receive the input yet, basically. That's what it's saying. You haven't received enough input yet, so if that is the case, then you're going to run a bit more. Yeah, just one step, and that is a kind of workaround for a bug that you were encountering, and it wasn't entirely clear how it works, how it ended up doing that. In loop counts how often it got -1 recently. Ah, yeah. Yeah. Okay, so if it received less than 2 times -1, so like half a step, then you're doing it one more time. Okay. And then you're saving ly, but how are you saving ly? Is it done globally? Ah, yeah, okay. So here you have a global last y, and it is overwritten here. And here you're checking if it is seen, and if it is seen, then you're breaking. And that's it. Twice in a row. Yeah. How many times do you get it twice in a row? But G, you're working on part 2, right? Yeah, okay. So you're working on part 2, and we're not confusing 1 and 2. And then in the end, you're saying that this first address is not in a loop. So that I guess you can quit also. And we're sending the input from, yeah, so here you're knowing already for sure that you've run all of your machines and they're done, and then you're sending your input to the machine, and then you're running it again until you've seen it twice. All right, that's a nice solution, and we learned something. We learned local scopes, or non-local scopes. Where was that? So it's a kind of similar to global, but is so you can apply non-local to your variables inside a function to indicate that this is an immutable variable that you're referencing from outside of your scope, and you need to do that because you cannot pass non-mutable values by reference. And now you got a G. Good job. Finally solved it. I'm glad that you tried and did not give up. Is there anyone else who has some code to share? Maybe G. I think we haven't looked at a lot of your code. If you're willing, of course, don't feel obligated. And I think Mr. 3AD also has an implementation. Let's have a look at that one. Thank you again, Alex, for sharing your code with everyone. So it was very helpful and very educational. We have a nice word for educational in Dutch that is a bit difficult to translate in English, but educational is the right word. So it's not guaranteed, of course, that I am able to run other people's code on my system, because sometimes you have dependencies, and well, if you structure your code nicely, then your dependencies are going to be all over the place. But Alex always makes extra effort to put all of his code together so that I can run it. Very kind of you, Alex. Let's see if Mr. 3AD's code can run here. You're saying, oh, Erkeni, you're asking, what does the word mean? The one that's hard to translate. It means educational. Yeah, what does it mean? That's hard to translate, right? Good one. It's leerzaam. That's the word that comes up very quickly, and in English it's just a very different word. It kind of means like learny-ish, very learny-ish. Lehrreich, yeah, exactly the same word in German. Yeah. Okay, let's start. We have a class for packet. It's a named tuple. Oh, wait a second. You're making a named tuple without using the named tuple function. How does that work? So you have a tuple with a name, or wait, this is a type. Oh, this is just a type alias. Ah, okay, I see. So you're typing everything actually. You're typing your computers, which is a dictionary between from ints to data computer. And you have queues. Okay, I see. I must say that it would be nice if PyCharm could highlight my types a little bit differently than my other code, because those types, they look different. Maybe we can do that. Color scheme. And then we have general and Python, and can we actually highlight types differently, like here? Type annotation, yeah. Let me make that a bit different, like purple, for example. I would like to use a kind of purplish color for that. Maybe this, if it's not too bright. Look at that. But I also want the first part to be annotated. But the first one doesn't actually get any highlight here. That means we cannot override the color of this thing here. And I'm not very happy with this color. Maybe I should make it a little bit more bright. Or maybe it's going to be too bright. Yeah, it's a little bit too bright. Okay, let me make it a little bit less colorful and a little darker. Maybe like this. Or maybe I actually even want to make it kind of invisible, because it's a kind of annotation and it's not super important, so to say. Yeah, like this. I'll keep it for like this for now. G, you're sorry you missed the question, but were you asking for your code? Yes, I was. If you still have some code that you want to share with us, please do, and we'll have a look at it. So this is Mr. 3AD's code, and he has a computer which is here, but he is importing that, of course, from another file. So we cannot go into that, but we can have a look and see how it works technically. So we have a main function and we open day 23, reading it, and actually you're doing read. I'm curious how that works, because I'm always using read lines, but maybe read is also helpful. Read just returns a string, I suppose. Let's use this docs, this Python docs file.read, or just read, io.read, or what is it actually, handler.read. Read without arguments returns the entire content. Wow, that's handy. I could have used that quite a few times, like rather than reading line by line and then getting the first line and splitting that, I can just do read. Okay. And then you're going to, oh, but wait a second. This is your input file and you're reading it, which returns data. And then you're saying, oh yeah, solve returns that. Okay, so solve is the main function. And you have a dictionary of computers and of queues for each computer. I guess that is the input. And you have a queue that keeps track of whether or not all of the computers are always transmitting. So basically, not entirely sure what is going to be in here, but we'll see about that. So for each address, you initiate a new computer and you're putting some data into it, which is the address of the computer, and you have a queue for that computer as well. And now you have computer.items, which is the sender's address, so the computer's address. And thanks, G, by the way, for sharing your code. I will look at it after Mr. 3AD's ones. And we're running the computer until there's input, very clear to read. And as long as there is no data, then we're going to do some interesting things. What is receiver? So I see. So we're getting 1, 2, 3 variables, and the first one you're going to load into receiver, and all of the rest, which means the other 2, into a single tuple called packet. That is amazing. I didn't know you could do that. I'm actually going to have to keep a list of notes of cool things that I learned, because I learn a lot, but I don't always keep notes. But this is one that I'm going to keep. Yeah, because I have been doing it differently so far. I've been doing like receiver, X and Y, blah, blah, blah. And then my point is X and Y. But you don't need to do that. I do know the other way around though, which probably most people know, is that you can do something like X and Y in case you have like who and then a position which has like 10, 10, extracting those nested tuples values directly into separate variables. So this is kind of the opposite of that. So you're running all of the computers as long as they don't need input, and when they do need input and they don't have data, then you're going to get data. How does that work? So basically you're reading from the output, right? Data empty, I think it is the output. So you're reading output from the computer, and then if it's 255, then, not part 2, funny, then you're going to append a particular packet to the list of values that are received by the NAT, and continuing to the next iteration of the loop where you are receiving more output. And when there's no more output to receive, then you're going to the next section, which is looking at the queue. But so far we have not done anything with the queue, I think. We have not, or we have populated it with an empty queue. And oh right, I missed this part. If you get an output packet, then you're going to append that packet to the receiving queue for that particular recipient. And then you're going over all of the recipients, and if they have a queue that is not empty, then you're going over all items in the queue. Hold on a second. So you have the queue per receiver, and if there is a queue, then you're going to loop over all items in the queue. Okay. And then you're saying the computer that is the receiver, you're going to put X and Y into it. And so I guess data put is a generic input function that I have too, which takes a variable list of arguments. But this is not optimized specifically for this puzzle. And if there's no queue, then you're going to give it -1. Nice. And then after running through all of the queues, you're going to run again until input. Now I'm kind of curious why you don't run until input in your second loop, because you already have that set up right here. I'm not sure what the difference would be in the implementation. I think probably don't deeply understand your implementation well enough to know that. And after that, if all of the computer's data is empty, so they all have no output, that's a nice way to check it also. Then what? Then what happens? If the length of not always transmitting is more than 1, then you're returning the last Y value. Okay. And also if the last two Y values are the same. Oh, actually that is interesting, because I just realized that the question is, when is it delivered twice in a row? And I didn't check for that at all. I just checked when do we have it twice. So technically our NAT could have output those values differently, and it would not have worked. So my answer would have been wrong. But luckily, the NAT outputs those double values twice in a row. Always. Yeah, so were we lucky then? Or was this actually by design? Does it depend on the puzzle's input, or is this the same for everyone? And I see that Mr. 3AD has handled it correctly, according to the instruction, and you missed it and submitted a wrong answer. Oh, so that means we were lucky, really. Well, I feel it's a little bit unfair now that I got it right so quick. Well, yeah, it's of course up to Eric to make sure that this doesn't happen. And it was, of course, also not intentionally cheating. It was a coincidence that we passed the test correctly by accident. And you're appending to 0, Q0, for the first computer, the last value that was received. Ah, now I know why you call it not always transmitting. That was so confusing. It's the NAT, and the NAT is not always transmitting. That is its name. Ah, I completely forgot about that. So that's why it's called not always transmitting. Okay. And then you get the answer. In the end, you return the last value, the last Y value sent to the NAT. Cool, nice. And thank you for teaching me about argument or assignment destructuring. I think that is a nice name for it. And so thanks again, Mr. 3AD, for sharing. Let's have a look at someone else shared some code as well. Need to scroll a bit. Gee, there we go. And Arcanian, you're saying in 2017 there was a question that involved a tree search. It wasn't supposed to be solving using depth-first search, but a lot of people had inputs that could be solved by DFS pretty quickly. Your first solution just looped over random DFSs until it got the solution. And your second solution did it properly. Ha, cool. I think I might need to try DFS on day 18 because I haven't solved that one yet. Maybe that's the way for me to try it as well. And does anyone know a good ad block for Safari? Safari is not my favorite browser, but I'm using it for streaming so that I don't get like all the things I'm looking up and stuff that I'm working on the stream, and I just have kind of clean browser. But I do have ads here, and I wasn't completely clear about which ad blocker I can install on Safari that is kind of safe to use also. G12345.py, and I need to change my input. I remember that. txt is here. Wow, what just happened? Day23 input, and there we go. Now we should be able to run it. If you use Firefox, you can make a container for the stream. Ah, is that like a profile? That could work. Okay, so it's running and you have some nice logging also, similar to what I have. I like that. And it is probably sleeping also a bit. Did you put sleeps? Yes, you did. Oh, you actually put a sleep inside your intcode machine. So it's kind of running gently and slowly until it's done. And then you have an answer. Nice. You haven't played with containers very much, but you remember they were meant for separating different browser use cases. Okay, let me add that to my to-do list. I have Todoist for my to-dos. It's a very handy app. So I just say check out Firefox containers with priority 3. It's not that important, but I still want to look at it, and let's do it today. Thank you. So let's look at the code. So actually it looks like your entire intcode computer is here. You have a global list of computers, and I remember this. Hey, gee, I remember this code. So you have your code for a computer. That is kind of the standard memory. So you're reading your code into a big array, and then you're adding 5,000 zeros just to give it a little bit more memory. And this is kind of your template that you're going to use for all of your computers. So you're basically copying all of these, basically a memory dump. You're copying a memory dump for each computer, and you also specify the index, which is where your instruction pointer is, relative base, list of inputs and outputs for every computer. And of course, what is very noticeable is that you're not using classes here. Do you have a special preference for not using classes, or did you have other reasons to use a list of variables instead of a class? And Arcanian is saying you recently switched over from a Google Task to Dynalist for keeping to-do list. Well, that is something I will also check out then. Check out Dynalist. Maybe tomorrow. Yeah. Oh, you're not good at writing code in classes. Okay. Well, if you want to learn about classes, I don't mind to teach you a thing or two. Classes can be handy in that basically you can do all of this. You can make copies easily, but oh yeah, this is also a copy, of course, and not too complicated. And 3AD, you prefer to forget your to-dos, that way you actually don't have to do them. Now, I started to keep my to-dos on a list because actually I forget so many things. And the thing is, there are always some things that you really need to do that are important, and if you don't write them down, you're forgetting about them, or if you're not forgetting, it means you're constantly spending mental effort to remember them. And it gives me stress, like, you know, walking around in the city, getting some clothes or something, and then in the back of my mind I have to remember that I need to do a laundry, for example, and just doesn't allow me to focus on what I'm doing at the moment. But if I know that I have a to-do list, I can just, you know, be outside, forget about everything, and when I come home I check my to-do list and see, ah yeah, laundry, right. So for me it makes my life a lot more chill. And for Arcanian, using to-do lists has massively changed your life for the better. I'm so happy to hear that. And also happy to hear about fellow to-do list users. Yeah, and especially what I like about my to-do list. Let's see if I can share what I'm doing. I do want to be careful not putting too much private stuff. Yeah, I can show you my to-do list. Although it would kind of go out of screen. So this is my to-do list on the right. So I have priorities, and I have like medium priority, like checking mail, and then I have high priority. So I need to draw an illustration for a company yearbook that we're making, and I want to learn .NET. And I am reading every day a bit, but it's lowest priority. And if I am, oh yeah, and I have of course some other things like Anagon Live. And if I'm starting my day, I just check P1 to see what is really most important. Those are the things I really cannot skip out on. And if I have time left, I will do P2 and P3. G, you're saying to-do lists are useful if you want to forget the things you need to do for now and concentrate on the stuff you're doing right now. Exactly, that's what I feel as well. And also, there are so many opportunities for exploring that you would completely forget, like reading this book or reading that article, or maybe, how about catching up with an old friend? Like, there are some friends that I talk to like a few times per year, basically, because we live abroad and we only Skype. But if I make a to-do item, just I put it in my calendar, like in 1 month, let's call that friend again. Then we'll actually get to talk a little bit more regularly, because time flies. Well, okay, that was a little bit of an intermission about to-doing. Let's stop the code. So we have a completely classless piece of code, and we have a global list of computers and the net X and Y and whether or not the net is empty. So if CNRs was actually, CNRs is, oh, that's actually what is passed into the code, into the function, and you're running it like here. Oh, you're running it in multi-threaded mode, okay. And wait a second, the target is run and you're passing arguments. So you can do that actually, so you don't have to make a new function to be able to run a thread with arguments. You can just do args. That's another thing that I learned. Let's keep it in my notes. And so you're running with every computer, and that's the computer number actually. And you're adding, you think you can code in classes, but you find that most of the times you're just writing a lot of extra fluff when writing classes. And thanks for the offer though. Totally fine, yeah. I do understand that. Class-oriented programming or object-oriented programming does tend to kind of push you into making a lot of boundaries and like not using globals, which is good for writing big maintainable code, but for small like one-off projects, it might give you a lot of overhead that you don't need. And you just read all of this today about threading, so today you've learned writing threading in Python, and it's also new for you. Cool. Wow. Advent of code is really such a good way to boost your learning, your computer programming learning and algorithms. So if your computer number is bigger than 0, so it's not the first one, then you're saving it as the global. I see here what you're doing. So you're actually overwriting a global computer here, no? No, you're not. You're just taking the current computer from the global list of computers, that's all. And then you're extracting all of those pointers. And here you have your basic loop. And it's amazing how you're able to handle all of the different output modes into such a small piece of code. So you're taking your instruction and your arguments, the modes and such, and here you're determining the length of every input instruction or opcode instruction. Also very simple. And if the length is more than 1, you're doing some things and otherwise other things. And here you're handling the different modes. And you're working on a very low level way, which means that your code is very short and precise, but it's going to be a little bit harder to read. So only if you know how an intcode VM works, you're able to read this, and I do. So I know that here you're checking for the mode of the first argument, and that means that your index is going to be the index plus 1, and otherwise it means that you have to take into account relative base and dereference that index and so on. So I'm going to collapse this piece because I assume that this was working well before, but I do need to check quickly if you didn't change your machine in any way for handling day 23. And it looks like you didn't, I'm not sure exactly. Yeah, I think you haven't changed your computer, in fact. And so when it did one run, you're returning the output. Yeah. And you have an input and output function that did change. Okay, maybe we can find it here. So here you're handling your inputs. And if you have inputs, you're popping, and otherwise you're returning. You're actually passing -1 into the position where you're writing. Yes. I guess this might be one disadvantage of not having a class, that it's very hard to adapt your code to different situations and make it more generic. So you kind of have to copy your code and change some things. But who knows, maybe that is just the easiest way for you to get day 23 solved as quickly as you can. And I spent a lot of time, you know, on my abstractions this morning, trying to make it asynchronous and with generators and stuff, and in the end it took me like a very long time because of that. And the output is also a bit different. So if your output is 255, then you're doing something different. You're saying what the last x and y was, and saying that your net empty is no longer empty, and resetting your outputs. And otherwise you're actually going to dereference the computer, taking the first address from the outputs, and then 3. What is 3 exactly? Computer 3 append the outputs. Oh, 3 I think is the position of the output list for that computer. Yeah. And then how do we start? So we start by running a thread, running the code for each computer. And now this is kind of cool that you're running all of them in the same time using a global computers array. Yeah. And you're saying basically you go to the random computer and insert stuff into the input queue. The random computer, it's just the next computer, right? And you're starting the thread, and then you're sleeping a little bit. Yes. And part 1, where is part 1 printed? I think part 1 is printed in the machine or not. Yeah. So you decided to post your int code implementation? Okay, I'll have a look at it in a bit. So G, remind me where you find answer 1, the answer for part 1. So here we have 255. And so the first output is stored in NAT_y. So NAT_y, that is probably, yeah, that is the answer. But how about for the second time? So you have rec, that is probably your recording of the previous one. So if you're running it twice and then you get another answer, then here you're printing it. And here, this is actually your answer for part 1. Yeah. Okay. And that's how you run it. Okay, cool. Thank you very much, G, for sharing and teaching me about threading, and of course about using functions instead of classes. And those functions can still have their own data, just using an array, for example. Yeah. That's an interesting way to solve it. Cool. Okay, so Mr. 3AD, you have your encode computer and you want to share with us. And I can add GIL to my learned list, definitely. Well, the whole threading thing in general. Global interpreter lock, which means that you can run so-called multi-threaded code in Python, but it's actually never going to have concurrent memory access. Yeah. And you're welcome, G. That was nice. So I'm copying the int code computer of Mr. 380 all the way here. Let's make a file. Mr. 3AD. Yeah, there we go. Cannot create a file because we already have it, and now I just minimized my editor. Yeah, you know, I'm working on this big ass screen here, and I have code on the left, which means my neck is always turned left, and that kind of misaligns my hands with the keyboard, and I don't get used to it. Like, I can't get used to it at all. So Mr. 3AD int code. So you have a class with opcodes and modes, the same as I do, and you have a base computer, and you also have different versions of the computer. Cool. I was trying to do that, but I didn't manage to. So here are all your different computers. That looks very, very clean. And you also use type annotations here, of course. Yeah. And you have nice constants for all of your opcodes. I like that. I like to see in the code what you're doing. Like, let's say you're doing something multiplied by opcode size. You see that is kind of clear. No magic variables. Well, you have a bunch of them somewhere, like here. I remember this 10 is probably a new line character. Yeah. So these are all from the different puzzles that we made. And today you were using the data computer. And it extends from the base computer, actually. Okay, and you had run until input. I remember that. That was actually here. So import encode. Instead of importing encode, we might be able to do... Can we do S here, actually? Can we do Mr. 3AD int code as encode? Maybe. No. What we can do... Wait a second. Maybe I should call that day 23 dot. Yeah. As int code? Yeah, now it looks like we might be able to run it. Yeah. And how about the input file? That is... should be here. Day 23 slash input. Yeah, and now it says no module named that one. Maybe we're not running it from the right location. Yeah, we are. Okay, so here I have another weird problem. Day 23 is not a package. Okay, maybe I can make it a package then. Python package or just a file init.py, right? No. How do packages work again? I'm like, for the life of me, I'm trying to avoid making packages in Python. It just is horrible. It never works. Overwrite. Okay. Thank you. No, but it still doesn't work. So I'm running this from the root. Here is a package, and I'm trying to import. Maybe I made a typo. That is possible. Mr. 380 intcode.py. Yeah. And I'm aliasing it. And it doesn't work. So yeah, this is my big struggle with Python. I have not ran into it recently because I am only using my intcode computer, and that one does work. Only my intcode computer is in a package and everything else isn't. So day 9, you see actually day 9 doesn't have a package and I can still import from it. So I don't need to make a package for day 23 actually. Let's remove that. Can you try Ctrl+Shift F10? I can, except that my computer is a Mac, and that means that these shortcuts will be different. But I think you might mean running it with breakpoints, running it with debug mode. Let's see. Here we are. So I'm running. I have a feeling I'm running the wrong file or something. It creates a running configuration for the current file. Yeah, I have it. It's here. And the current work directory is the same as all of my other scripts, so it should be fine. Yeah. And what is a bit strange is that actually I'm importing here from the top, and even though I'm importing from the top, it kind of already starts doing a lot of things, even though I think it should crash already right away, right? Like, why does it run anything? Why is it running anything when there's nothing in this file? Maybe it's actually running my code instead of Mr. 380's, but no. Yeah, it's my outputs, yes, but why does anything happen at all? Look, my file is completely empty. I'm only importing the intcode computer, not doing anything else. Or is the intcode computer running by itself? Is it running on the input.txt or something? No. Maybe Python is caching something by accident? So when I import the int code, then it will work. Then it's going to do something. But I haven't passed it any input. So how can that be? Well, it can. Okay, so maybe it just starts or something. But you don't have a main function in here. So nothing is being started. I have no other code. This is kind of weird. Did you kill threads from your program? No. And also, this looks like my output, actually. This doesn't look like your output at all. Oh, look at that. I have two. No. Mr. 3ad.py. I think my Python is really messed up or something. Like, it's really messed up. I do tell it what the right path is, So let's look in the terminal and see if we can run it from there. Wow. So we have day, no, we don't need day 23. We can just run Python like this. And now it says no module found day 9, but I'm not actually trying to run that. So this is my code, right? And Mr. 3AD's code looks different, doesn't it? Doesn't it look different? Yeah. Okay. And it seems that as soon as I'm importing, that everything else starts running. Well, I'm not sure what is going on here. We have a big mystery, some weird voodoo shit going on. So I'm just going over your Encode computer and looking at it, just like that. If anyone else has a solution for day 23 that they want to share, please do go ahead. On day 9 you did from import from, and here you did import as. Yes. What I was trying to do, so there's two questions. So here I'm importing int code and I'm trying to rename it to something else. That's all I'm trying to do. Yeah, that's all I'm trying to do, just making an alias, because in Mr. 3AD's code, the int code package is called int code instead of Mr. 3AD int code. Can you navigate to the day 3 folder and remove Mr. 3AD from import and then run from the terminal? Like this one, you mean? Remove it from the import. Yeah, okay, so like this as int code, and then run it from the directory itself. Yeah. Like this. Okay, and then we get an error on the file. That is fine. And what else happens? We get an error that our assertion is wrong. Okay. But what is this? And the import works. Oh yeah, my input is not the same as yours, of course. So that is okay. It's not that much different actually. So I can replace it. Or that was actually the second one. The first one is another one. So that is working actually. Yeah. Okay. Well, you're starting to see my problem with Python and packages. It would be nice to finally understand it. But also I feel some resistance because it's always so kind of confusing. So your encode computer is pretty clean. I would say you have handlers for input and output, and I think you're using queues actually. So I'm not sure if you have handlers to handle something when output occurs or input. I don't think you do. And you have a get all and put and stuff and is clean. Oh yeah. Yeah, that looks pretty nice. And your base computer, how do you do that? Ah, nice with lambdas. Yeah, I like that. It looks very clean. I would even go as far as writing it on same lines like this. Ah, but then the lambdas don't align very well. I see. Okay. Just getting stuff from the DQ. Popping left and adding right. You hate callbacks though. But you did make callbacks here, or you mean it in a different way. These are not really callbacks, they're just handlers. Yeah. Handle multiplication. Yeah, so you're deciding how many arguments you're going to get from your input, and then passing all of those as output Yeah. So let's see how you handle additions, for example. So you get A, which is a pointer, and B is a pointer, and oh, and then you're adding them. But how do you make sure that you're handling the memory addresses correctly? Did you also do what a colleague of mine did, which is make memory a class which overrides the getter? And let's see, memory is a default dict, okay? So it's not a special class, and the memory location handler is in the get arg. Ah, okay, yeah. So this is something I might want to share. I don't have the code right here. Well, I do. I have not asked for permission to share this on the stream, but I think you'll be okay with it. Can I find my advent of code and my friend's fork? So I'm going to show you something that my colleague did, which I think was a really cool solution for the int code computer. He made it in Kotlin. Ah, right. Oh, yeah, he made it in Kotlin. So that is something you might not be able to do in PyCharm or a Python, but maybe you can. So for day 5, it looks like this. It's very small. There might be another one in day 7. No. Maybe in day 9. I think he might have not committed. Ah, he didn't commit all of his code. That is unfortunate. So I'll share with you in words what he did, and that is basically make a class of memory so that it looks like a dictionary. So that means that you can address items from that memory like this, like let's say 120, but in fact he made pointers so that you have a pointer class, let's say 100, and that one would be absolute or like relative, for example. And then using Kotlin function overloading, he overrode the getter for the dictionary, and then depending on what type of pointer you pass into it, you would get a different address. And so your accessing of memory looks very similar, just using index operation. It's very clean. I'm not sure how it would be in Python because you don't have kind of polymorphism in functions, but you could type check, of course, or yeah, check what kind of position you're getting as an input. And callback hell, you're pointing out callback hell. Yeah, that's something that we are all familiar with, of course. And promised to solve this problem. Still not a super big fan of promises, but they do seem to solve this issue. So the get next arg, that is what solves the issue of the different modes. Yeah. So you're parsing the mode from the instruction, and then if you have position, you return the value, otherwise the pointer. And what is nice is that you're returning a pointer object instead of actually the actual dereferenced value, because there were cases where you're writing, and when you're writing, you do have to take them as absolutes, even though the mode, according to the instruction code, is actually immediate, or rather position. Yeah. So where are you getting your next args? And so for input, for example, you need to know where the pointer is located, and you have a not implemented error. Maybe you override it in a new one, like data computer. Yes. Ah, that's how you actually extend your original computer. Very clean. Yeah, that's something I would do. But you were not able to avoid adding the opcodes that were not available in the original int code computer into your main function. This is the problem I had also. So I wanted to make a nice class hierarchy where all of the new opcodes that I added day by day were added to the new child instances, but I couldn't avoid every time to add something to my base class to make sure that the right things are handled. And then in the end, I decided to actually just put everything in the base computer because my OOP skills were coming a bit short. at that point. And base computer is an abstract class, so you can't create an instance of it unless you subclass it. Okay, I see. Yeah, and then you have, let's look at the different classes. So you have your console computer that just takes data from the console and prints it also. I see. And an ASCII console program, a computer extends from that, and it, I see. And it takes input as strings. Yeah, so it's actually going to take the character code for that character as input. And you're reading from input. Nice. Cool. Okay, thank you very much for sharing, Mr. 3AD. I will double check the chat to see if anyone else has some code to share. And if not, then I'm going to round up. I still have day, what is it? Let's look at the calendar. I still have day 22 part 2 to do. I'm not very much looking forward to finishing that. I still have the puzzle with the maze and the doors to do. I have a solution, but I still haven't made the time to handle that exactly. And also I have to upload a ton of videos to YouTube and to highlight them on Twitch. I haven't done that yet. So that's what I will try to do today. And then tomorrow we'll just continue with day 24. 2 days left. And what I would like to do on day 26, yeah, I should put them on my to-do list, actually, you're right. What I want to do on day 26, if people are going to be available at least, is to go over some of the previous puzzles that were very hard. If you have any suggestion for which puzzles you would like to look at again, then do send me a direct message on Twitch or on YouTube if you want. And then we'll kind of look at the most popular puzzles. So thanks all for watching and hanging out and sharing so much of your solutions and helping me out figuring out where my code is wrong or my interpretations were wrong. See you all tomorrow. Tot morgen and have a great day. Goodbye.